Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today our goal is to focus on our Algebra 1 Big Ideas, Chapter 1, Chapter 3, sections 1 through 4. This is a review sheet that I had a student submit, and a few students actually, they were really struggling with it. So I figured I'd make a video to help others as well. We are here doing California State Standards, Common Core State Standards, the Big Ideas book, Chapter 3. This is the first 4 sections, and this is a review for a quiz. So without further ado, we're going to start with find the domain and range of the function, right? So when I have different points on my graph, and I'm looking for the domain and the range, one of the things that I want to make sure that we're aware of is that domain is all of my x values, range is all of my y values, right? So I know that this is my x-axis, this is my y-axis. Again, here's my x, here's my y. I'm looking really for all of the x values on my graph. So in the first problem, my domain is actually going to be all of the x values. So on the graph, it actually didn't label all the points. It just gave all the points. But basically, because I'm doing a whiteboard, it's like a little bit different. So it's not as easy to label all the points and the tick marks and whatnot. So I just labeled the points as is. You would actually have to go in and figure out, hey, this is -4 on the x, and this is 2 on the y, okay? So here we are looking just for the x values. So this is one x value, another x value, another, and another. Meaning all of those values are going to be in my subset. So some teachers do like this, that is not a fancy pants bracket like that. Fancy pants brackets like that, and then they put in all of the values. So for example, -4, -2, 0, 2, and 4. The other thing that I've seen is just a list. So no fancy pants brackets, and I'll give that information in here. So for example, when I'm looking at the range and I'm looking at the y values, I've got -2. Notice how 0 appears twice. So we only have to show it off once. And also 2 appears twice, and we only have to show it off once as well. So I've seen teachers accept responses like this as well. So without the fancy pants brackets. When we're looking for the domain in this type of graph, we really want to make sure that we know the very bottommost value and the very topmost value, and then the value most on the right and the value most on the left. So we're kind of creating this little box, if you will, of where my function, where my graph like starts and stops. And the way that I can do that, or the reason that lets me do that, is because I have a point here and a point here. So I know my function starts and stops at these 2 points. If they don't start and stop at specific points, then we know that it goes on forever. And we'll talk about one of those in a later video, in a later problem. Okay, so in here, my domain is between -5, right? Because again, my domain is all of my x values. It's between -5 and 4, and everything in between, meaning all of these values in between on my x value list, those are all part of my function. So I know that domain is x values. I also know that when I have an open circle, that means I either have a less than or greater than symbol. And when I have a closed circle, I have a less than or equal to or a greater than or equal to symbol. So in this case, because x is in between these two, we're going to put, less than and less than or equal to. So this states that -5, from -5 all the way to 4, those are my values for the domain. Another way of labeling it, of listing it. And then my values for the range are going to be from the lowest point to the highest point. Well, since we're only focusing on the y values, I have -2 here, I have 4 here. So my lowest value is -2. Because this is technically a filled in circle, we're going to do or equal to, and we're going to do the same thing here, or equal to. Now, one of the questions that I normally get is, how come, Anna, do we not really focus about, or do we not really care about these particular numbers, this 1 over here and this -2 over here? And the reason why is because 1 is actually included in here, right? I know that -2 is less than 1, which is also less than 4. So since 1 is included in here, my y value, right? This is the y value of the point. Then I know that I don't need to state it separately. Same goes for this, -2. -2 is actually in between -5 and 4. And so -2 would fit in snugly there, and the statement would be true. So I don't need to state those two numbers at all. Okay. Oh, whoops. Let's talk about page 2. So page 2 says find the value of x. Now, some of these problems were actually multiple choice questions, and we're not going to do the multiple choice questions. Like, I'm not going to give you the answers, only because it doesn't quite make sense for me to do that. And you won't necessarily have a test with multiple choice questions, right? So we're just going to go in and we're going to solve the problems as is. If you do have this review sheet from this particular high school, then definitely just, click the correct answer, right? Okay. So I know in here I have n of x and n of x, and they both equal two different things. So one of them equals this, one of them equals this. Since they're both n of x, and since both n of x's equal two different things, I can say that those two different things equal each other. In a sense that I can say 7x minus 5 is also equal to 23. And then this just becomes a two-step equation that I can solve, right? So I'm going to add 5 to both sides. 7x is 28. Divide by 7 on both sides. X is 4. Final answer, that's all we're doing in this particular case. They're just saying, hey, solve the equation in a fancy pants way, right? At this point, we're in Algebra 1, we're looking at more algebraic thinking, more conceptual versus like very concrete, right? So whereas in middle school, you just be given this, on the algebraic level for algebraic thinking, you're given this and forced to derive that. In here, we have the same exact thing. We have q of x and q of x. Q of x equals this and this. So I'm just going to set them equal to each other. 4/5 x minus 9 equals 3. I'm going to add 9 to both sides. 4/5 x equals 12. Then I'm going to multiply by the reciprocal, 5 over 4. 5 over 4. I can turn this into over 1. Simplify. 4 goes into 4 once. It goes into 12 3 times. I know that these guys cancel, so I'm at x is 15. Final answer. Okay, then we're given a word problem. So usually with word problems, I like to make sure that I highlight important things, that I know what the things are that would be super helpful, right? So it says you spend $3.50 on fruit. Apples cost 20 cents each. Oranges cost 30 cents each. The equation, blah, 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 models the situation where X is the number of apples. Not trying to make sense, right? Because apples are 20 cents. So I have 20X, right? And Y is the number of oranges. Again, that also makes sense because oranges are 30 cents. So I have 30 cents times the amount of oranges. Which of the following is not? So this is a super important thing, not a possible solution in the outcome, in the context of the problem. So this is what I would do in order to solve a problem like this. I would go in and I would say, okay, I know that I have 20 cents times X plus 30 cents times Y, and that's going to give me $3.50. I also know that if I were to replace the X and the Y, I would replace it with the number of apples and the number of oranges, which all of my answer choices give me those possible numbers for apples and oranges. So I'm going to physically replace this X and this Y and see if do the two sides of the equation equal each other, okay? So let's start with the first one. So the first one says I have 0.20 times 1 apple plus 0.30 times 11. Does that equal $3.50? So this is going to be 20 cents plus $3.30. And does that equal $3.50? Yes, this is true. So this is not a good answer choice because it does follow the story of the problem, right? The problem story, the story problem, whatever it's called. And we're looking for something that does not. So that is not a good choice. Okay. So the second one, I have 20 cents for 7 apples plus 30 cents for 7 oranges. Does that equal $3.50? So this is $1.40 and this is $2.10. When I do add these together, again, they are equal to $3.50. So also it totally follows the story. Let's take a look at the third one. So I have 20 cents by 11 apples and 30 cents by 1 orange, decimal point. Does that equal $3.50? So this is going to be $2.20 plus 30 cents. That is in fact not $3.50. That is in fact $2.50. So we've just found our answer. Now, before we move on, I like to make sure that there's not like one of these questions that say, select all that apply, because you're gonna have problems like that. You're gonna have questions like that. Whether it's this test or another test or any sort of state test or standardized test, it's possible that you can have one that says select all that apply, and we just wanna make sure, right? So it doesn't say it here, but maybe they forgot, maybe it's a typo, who knows? Let's still check this guy. So I have 20 cents times 4 apples plus 30 cents times 9 oranges. Does that equal $3.50? So this is 80 cents plus $2.70, and that does indeed equal $3.50. So I know that that's not a good choice. So I know my only option is 11 apples, 1 orange. Now that I've satisfied my soul, my heart, I can go in and move on to the next type of problem. Okay, so here we are. It says to graph the linear function. One of the things I want to make sure that we know, and it's super important, is anytime we have f of x or g of x or w of x or f of w or whatever the case may be, anytime I have something in this format and the letters can change, that is the same thing as y. So I can replace this guy with y equals -2. I can replace this guy with y equals 2x minus 3. Again, this guy with y equals -1/2 x plus 2. So the reason why this is important to do, or the reason why it's important to name it this way, is because every Algebra 1 student basically goes through 8th grade math, or the math that you did the year before Algebra 1. And the first semester of Algebra 1 kind of like condenses all of 8th grade math, right? And it adds a few new things and it expects a little bit more from you, but for the most part, it's the same concepts over and over again, right? So here we are, we know how to graph this from last year. We know that we're going to find where y is -2. So here's -1, here's -2. And we're just going to create a line that goes across. Here's my x and y. That goes across my -2, where y is always going to be -2. Totally fine. We're in a good place. All right. So now I have an x and y here. I also know from last year that this is called slope-intercept form, and same applies in here. I know that I need to first find my intercept, my y-intercept. So -3 is that y-intercept. So I'm going to go 1, 2, 3. And that's going to be my first point. Based on my slope, I know it's a positive slope. So one thing I know is a positive slope. So it's going to go in that direction. Oh, whoops. I think I clicked something on my tab. There we go. So I know it's going in that direction, right? And I know that my slope is going to be 2 over 1. So I have a numerator and denominator. I have a rise and a run. So I'm going to go up 1, 2 over 1, up 1, 2 over 1, so on and so forth. And I can continue. Hopefully your graph looks a little bit better than mine. But I think this is fully acceptable if I have at least a few tick marks and I'm showing where I'm moving, things like that. Okay. And then this next one is the same business. Whoops, that is not a better line. Here's my X, here's my Y. Now I'm looking for the y-intercept of 2. So I'm going to go up 1, 2. And I notice that my slope is -1 over 2. So negative slopes go in that direction. 1 over 2 means I'm going to go down 1 over 2, down 1 over 2, right? So I can kind of create something like this. And then, again, I really hope your graphs are a little better than mine, but the concept is still there, okay? We want to make sure that our points actually touch the lines, things of that nature. Okay, so this is video 1 of a few videos. I actually don't know how many videos I'll be making, probably 1 of 3 videos. And then definitely make sure that you come in and see the rest of them so that you can get a better grasp on this chapter 3, sections 1 through 4. Bye.